Solving rational equations. A strategy that we're going to use is that rational equations are easier to solve if we eliminate the fractions. And we do that by multiplying all the terms in the rational equation by the LCD. Remember, the LCD is the least common denominator. So let's look at an example. We'll look at x plus x squared minus 5 over x squared minus 1 equals x squared plus x plus 2 over x plus 1. So our first step is to factor the denominators. Okay, so the first term is just x. Its denominator is 1. It doesn't need to be factored. The second term has a denominator of x squared minus 1. This is a difference of squares, so we can factor it. The square root of x squared is x. The square root of 1 is 1, and one of the terms gets a plus, the other one gets a minus. And then our last term is x plus 1. This does not need to be factored any further, so it's already factored as well. Then, now that everything is factored in the denominators, let's find the least common denominator. So let's look at all the denominators. We have a 1, and then in the second term, we've got our second expression, we've got x plus 1, we need that. X minus 1, we need that. If we go over to the last expression, we have x plus 1, but we already have that. So this is our LCD, and we don't actually need the 1, so I'm erasing it. So our LCD is the product of x plus 1 times x minus 1. I'm just going to rewrite this so that we have everything all clear so that we can do our next step. Because our next step is to multiply all terms in our equation by the LCD. So I will multiply all three of these terms by x plus 1 times x minus 1. So I've got the first term multiplied by x plus 1 times x minus 1. And I'm multiplying these in the numerator. I could put them over 1, but I'm acting like they're all in the numerator. And then I'm multiplying it by the second expression and then the third expression. And then our fourth step, let's cancel the common factors. When we do this, the fractions should go away. So when we cancel, remember we're left with 1s technically. So the x plus 1's canceled, the x minus 1's canceled in that second expression. And then in that right-hand side expression, the x plus 1's cancel, but that's just it. Okay, so then we will simplify. So on the left, that first term, we've got x plus 1 times x minus 1 times x plus, so we've got a whole bunch of 1's, but we're left with x squared minus 5, and then equals, and then I've got on the right, I've got 1 times x minus 1, and then times the x squared plus x plus 2. Okay, that looks a little bit easier. Now let's do some multiplying. X times x, I've got x squared, x times negative 1, negative x, 1 times x plus x, 1 times negative 1 minus 1. And remember, this is all in parentheses, still times x. And I still have plus x squared minus 5 equals. And then on the right side, I can also multiply and distribute. X times x squared, I've got x cubed, x times x squared, x times 2, 2x. Negative 1 times x squared minus x squared, negative 1 times x minus x, negative 1 times 2 minus 2. Okay, let's continue simplifying. I still have x squared in parentheses on the left, but this negative x and the positive x cancel, so I'm left with x squared minus 1 in parentheses, still multiplied by x, plus x squared minus 5 equals. Let's see if we have any terms to combine on the right-hand side. I have x cubed, then I have x squared and negative x squared, those cancel out. Then I have 2x and negative x, those combine to form plus positive 1x, and then I have minus 2. Still have some multiplying on the left. So I have x squared times x, which is x cubed. I have negative 1 times x, which is minus x, and still plus x squared minus 5 equals x cubed plus x minus 2. Okay, then we will solve for x. So because this is not linear, we have exponents, let's get everything on one side, 0 on the other. And I'll start that, I'll move everything to the left. It wouldn't matter, we could move it to the right. I'm going to start by subtracting x cubed from both sides. When I do that, they actually cancel out from both sides, and I'm left with negative x plus x squared minus 5 equals x minus 2. I'm going to transfer this to the next slide so that we can see where we're starting off at. So I'm not doing any new work between then and now. Still have my negative x plus x squared minus 5 equals x minus 2, but I'm moving everything to the left. So let's subtract x from both sides. Now I have negative 2x plus x squared minus 5 equals negative 2. Let's add 2 to both sides. So now I have negative 2x plus x squared minus 3 equals 0. And I'm just going to rewrite the left so it's in standard form. So x squared minus 2x minus 3 equals 0. And this is quadratic, and this should factor. So we're looking for two numbers that multiply to negative 3 and add to negative 2. Negative 3 and positive 1 will work. So I can factor my quadratic to x minus 3 times x plus 1. I can use the zero product property and set x minus 3 equal to 0 and x plus 1 equal to 0. Add 3 to both sides on the first equation and get x equals 3. Subtract 1 from both sides in the second equation and get x equals negative 1. Okay, I'm just going to rewrite our original equation, although I'm going to keep the denominator factored for the second expression. Our last step is to make sure or check to see if any of our answers that we got 3 and negative 1, see if any of those make the denominator of the original equation equal to 0. So let's check x equals 3. So remember, our x term has a denominator of 1, which will never equal 0, so we're good there. Well, let's check x plus 1. So 3 plus 1 does not equal 0. We're good. X minus 1, 3 minus 1 does not equal 0, so we're good. X plus 1 again, still does not equal 0. So x equals 3 is good. That is a solution for this equation. Let's check our other solution. So x equals negative 1. Let's see if it makes any of our denominators 0. Again, x, which has a 1 as a denominator, will never have a denominator of 0, so we're good there. X plus 1. So does negative 1 plus 1 equal 0? Yes. So this x equals negative 1 is not a solution. It is extraneous. And our only solution here to this equation was x equals 3.